right hand side, I've written down some numbers that you know, you have to know, in the sense at least you have to be aware of them. You probably could write down a page note like this and have it handy. And what you're looking at are called perfect squares. And we use them a lot when you want to simplify radicals, right? Square roots. I've got this one here missing right now, but I'll be filling that in later when we do perfect cubes. And we use them when we want to simplify cube roots. So let's just get you refreshed on simplifying square roots. If you want to simplify the square root of 40, if you remember what we did last time, don't you have to write it down as two numbers, one of which has to be a perfect square, and you try and find the biggest one that you can. And I believe in this particular question, 4 times 10 does the job. And the square root of 4 gets you 2, and then you're left with the square root of 10. So basically, that's what the square root of 40 simplifies down to. It just simplifies down to 2 root 10. We are going to be using that quite a lot today, that process. Secondly, do you know if you have the square root of 3 and you multiply it, say, by the square root of 6, you are allowed to combine them into a single multiplication, 3 times 6, which is now the square root of 18. And sometimes that's you finished, but not always. Do you notice that the square root of 18 can be simplified? So you're going to have to find a perfect square times something else that gives you 18. Could someone volunteer the answer to that? How could you write 18?
9 and
2. Okay. And then that splits out as the square root of 9, which is 3, followed by a square root of 2, which kind of tells us then that if we wanted to simplify this multiplication, that's what you would get. And we'll be doing that a fair amount in 7.4. Now, it's all seem familiar, usual kind of process, how you simplify and multiply different radicals. So let's look at some examples of how that's going to happen. I'm going to start with numbers and then gradually get more and more complicated. So suppose you had the square root of 2 and you wanted to multiply it by the square root of 10 plus the square root of 20. Right, so that would be considered a multiplication. We have a name for this process. Have you ever heard, I'm sure you have, of the distributive law, which basically says if you have a thing outside and some other things in the bracket, you multiply the root 2 and root 10 together, and then you multiply these. So that's what I'm going to do. I'm going to multiply these two together plus these two together. And then it's a good idea to combine them before you simplify. So 2 and 10 gets you 20, and 2 and 20 gets you 40. Now, I don't think anybody here would want to do that, at least I hope not. You know you're not allowed to add them together and call it a square root of 60. You know, it doesn't work that way, right? They're just totally different square roots. But you can simplify them, right? Now, 20 can be called 4 times 5, so that gets you 2 root 5. And 40 becomes a square root of what? 4 times 10, and that gets you 2 root 10. And sometimes these two guys can be added together, but not always. These two guys can't be added together because isn't that root 5 and that's root 10? It's like two different objects. So that's actually the end of the question. That's the final answer. So far, so good. suppose, still on numbers, suppose we try square root of 8 times square root of 2, take away square root of 12. Square root of 8 times square root of 10 gets you square root of 16. Square root of 8 times this gets you the square root of 96. Do you see I've just did the multiplication in my head rather than write this line here down? Okay. Can you do anything about making the square root of 16 nicer? Yeah, quite a lot actually. Isn't that kind of lucky? It's a perfect 4. Take away. Right. 96 is a pretty heavy duty number, right? So we should be able to find somebody in this list times whatever's left that gets me 96. Could anyone find a number from this list here times whatever's left and get 96? Because there is a number.
6 and 16.
Okay. And what that's going to get me is 4 root 6. And I know this has got a 4 and I know this has got a 4, but because this has got a square root of 6 and this doesn't, again, that means we're finished. So there's some examples of just numbers right now of the distributive law. Okay. There's not much more to do with the numbers. So here goes square root of 27 plus square root of 6 followed by square root of 2 take away square root of 3. Now, when you see 2 terms multiplied by 2 terms, I hope FOIL comes to mind. F-O-I-L. So that's how I'm going to do this one. If you multiply the first together, call that F, you're going to multiply these two, and root 2 times root 27 is root 54. And then you multiply the outsides. In this case, 27 and 3, and it's negative because of that. And 3 27s, I believe, is 81. And then you do I, and that's the inside 2, and these two multiplied together give me root 12. And then you finish with L, which means the last in each, and that gets me the square root of 18. So far, so good. Now, each one of these guys, if it's possible, you should simplify it down to its nicest terms. Well, I'm going for an easy one. That middle guy is perfect. It's a 9, right? Can anyone see any mistake that I have made?
Should be negative square root 18.
Welcome. Right. So apart from that, everything's fine, right? So let's go one at a time. Square root of 54. Somebody in here is going to work with 54. somebody in here works with 54?
6 and 9.
Okay, which is going to get me 3 root 6 and take away 9. I'm picking the easy one because I want the easy ones for me today. 12 is 4 times 3. So won't that get me 2 root 3? 18, I believe, gets you 9 times 2. Won't that get you 3 root 2? Quick search, different. Can't do anything else. That horrible mess is the answer. Now let's do one that has a nice answer. Square root of 7 plus the square root of 8. Square root of 7, take away the square root of 8. Now that's going to come out really surprisingly nice. You should be amazed, well I would be anyway, at what the final answer is. So let's see it out. There's the F of FOIL. Well, I can do this 2 ways. Isn't the square root of 7 times the square root of 7 the square root of 49? Isn't the square root of 49 just the number 7? So can you imagine me just saving a line of working and calling it 7? Now, if you do the outside, the square root of 7 times negative that is take away 7/8 is take away the square root of 56. When you do the inside, isn't square root of 8 and square root of 7, this time positive, the square root of 56? And then the last two, square root of 8 times negative the square root of 8. Doesn't that end up being negative the square root of 64, which is negative 8? And something really nice happens here. Do you notice these two middle terms kill each other off? You see that? Oh, wait a minute. Doesn't that 7 take away 8 get you negative 1? So that horrible multiplication ends up being a very surprising answer. Would you agree you probably weren't expecting negative 1 out of that mess? Considering what you typically get out of these messes, that's quite amazing that it comes out so nice. Still on numbers, and pretty much just one more example with numbers and FOIL. Suppose you were being asked to do that guy, right? To multiply it out and simplify the result. That's typically what you've been asked to do. Wouldn't I have to write that as this guy times himself? I'm not going to do my little arrows with FOIL now, I'll just point. 2 times 2 gets you 4. 2 times root 2 just gets you 2 root 2. One of them's a number and the other's a square root. So when you multiply 2 and root 2 together, you just get 2 root 2's. Now if you go on the inside, wouldn't a root 2 times 2 just give you another 2 root 2? And what do you think you get when you do root 2 times another root 2?
2.
2. And in this case, we get quite a lot going on. They don't cancel each other out, but can you at least join them together? And that'll get you 4 root 2's. And can't you join together the numbers and get yourself 6? So this would be the answer to that situation. Okay, so do you feel comfortable about doing with numbers right now, FOIL ones, and we can find one, distributive law ones, right? Because that's pretty much all we've covered. So I'm just going to give you, well, I think I should be able to squeeze them here. I'm going to give you one of each just to try out, right? Just to convince yourself and me that we're on the right track here. So square root of 3, so this is the distributive one, with the square root of 27, take away the square root of 6. And that's the first one. And the second one is going to be root 3 add 2, take away root 12, take away 2. Okay, give you a couple of minutes, 1 minute each. Well, I can see most of you done. Okay. Square root of 3 times square root of 27. If you multiply those two numbers, you get 81. Subtract. Square root of 3 times that guy, you get square root of 18. This one is a perfect square. This one you can simplify. Would you agree that 18 was 9 times 2? And so you get 9, take away the square root of 9, which is 3 root 2. And that would be your answer. Can't do any more. You get that? Good. Okay. FOIL, I'll just do the point. Square root of 3 times square root of 12 gets you the square root of 36. Square root of 3 times the number -2 just gets you that. 2 times this guy gets you 2 square root of 12, and 2 times -2 gets you -4. Well, let's see what we have. This one is a nice number, and this one is still a nice number. Let's phrase it this way. Can you do anything to 2 root 3 to make it better? Nah, it's as good as it's getting. This, I don't know. This might have some mileage in it. Not the 2 part, but would you agree you could do something about the square root of 12? If I do it kind of over here, like side working, won't it be 4 times 3? Won't that get you 2 root 3? But you've got 2 of them. So isn't that 2 lots of 2 root 3? Which means that you've now got 4 of them. You happy about where that came from? Now, there's some nice things happening here. Sometimes nothing much happens and you're left with a whole load of mess. But would you agree the 2 numbers combine to give you 2? And won't -2 plus 4 of this get you positive 2 root 3? And now you're finished. So we're doing basically skill building, which is how to manipulate calculations involving multiplications with square roots, right? That's what we're doing. And we can do squares and FOILs and distributive laws and all that fun stuff. So we're now going to, still on square roots, do pretty much the same thing. But now instead of having numbers, we're going to have square root of 5x squared, right? And the square root of 2y and things like that to deal with, right? So before we get into the messy stuff, let's just do a quick recap. You cannot do anything to the square root of x. That's as good as it's ever going to be. On the other hand, what can you do about the square root of x squared? That can simplify, agree? So what's it simplifying to?
X.
Now we talked a little bit about this, well, probably a lot more than you, yeah. I mean, it's just the rule of the game, right? You just have to make it positive, and that's what's happened. Has anyone done the homework and found out that WebAssign is kind of, I don't know if the word is generous or careless about sometimes not worrying about the absolute value? Is that what happens sometimes? Sometimes you put it in and it'll be fine, and sometimes you'll forget to put it in and it'll still be fine. Is that right? Yeah. I can't help that, right? It's still true to have it, so I guess that's fine. Now, if you stick in a number and you put a larger power, like x to the 7 in, and if you want to simplify just that little package, what you really should do is split it into its two constituent pieces and simplify each piece. Right, so remind us how this goes. Won't the square root of 8 be 4 times 2, and that'll get us to root 2, and we've probably done enough of them to be able to do them in our sleep. Not so common, it's the square root of a power of x, right? Square root of x to the 7, right? Square root of x to the 4, square root of x to the 23 or something, right? Can anyone tell us what the square root of x to the 7 gets us? That's part of the answer. X to the 7 splits. I'll do over here. And you can think of it as splitting as an x to the 6 with an x left over. And then you can split it into its two pieces, just like you would do with a number. And then won't the square root of x to the 6 get you x cubed? So this guy gets me that. And now the last bit is tidying up. 2x cubed. See this guy and this guy, you basically bring them together inside a single square root and you get that guy. We are going to be doing a lot of that in the next 10 minutes. Where you'll have two things, at least one, if not both, will have x's in them or y's, whatever letter they want. You're going to bring them together first, and then you're going to figure out how to simplify, or how to separate it and make it nice at the end. And a little list back. So let's do the square root of x times the square root of x cubed plus 4 times the square root of x. Right, so this would count as what, a distributive law question? So I'll try and take every step I can. If you multiply these together, you get the square root of x times the square root of x cubed plus the square root of x times 4 times the square root of x. Now you can multiply these together just the same way that the square root of 2 times the square root of 3 becomes the square root of 6. You can multiply these together. And technically, if there's an x there, doesn't it mean there's one of them? So when you multiply this together, are you happy about how this becomes the square root of x therefore? Now, the numbers, just stick them at the side. This guy times this guy gets me the square root of x squared. Now, I've deliberately chosen this question because of one of the really cool things that happens. Isn't this a perfect square? It's a variable version, but a perfect square just means that the answer doesn't have any square roots left, right? And if you take the square root of something, don't you essentially half its power? So an x to the 4 becomes x squared. And an x squared becomes 4x. And that might be the answer. And that's also going to be the answer. Are we cool with that? I think what I'll probably do, to be fair to you, is that when you're doing the exam, the final exam, if a question like this happened and you type that in instead of this, I'll just give you the points, because I think you did so much work to get there. It seems a bit cruel to just take, to hit you at the end, when even the book that you're using, or even the software you're using, doesn't even follow its own rules. So it's been told, right, that sometimes it does and sometimes it doesn't. So it's not a surprise that you might forget that. Okay, that was the distributive law. Let's up the ante and do 2 the square root of x cubed. Actually, we'll make it the square root of x cubed y. That's more interesting. And have this as 3 square root of y plus 2 the square root of x squared y cubed. A pretty ugly one, right? So I'm just going to take it slowly. If you multiply this by this, you're going to do essentially that calculation, right? Plus this fella times that one. Now, I don't know. You might not even bother doing that. You might do that in your head. But here goes. 2 times 3 gets you 6. When you multiply this square root by that square root inside a single square root, are you happy about a cubed y squared? Or x cubed, I should say, y squared. You see the x cubed, and then y gets you y squared. Now, if you multiply these together, the two numbers get you 4. And then you're going to have this guy times this guy, which is what, x to the 5. And y times this guy is y to the 4. Are you happy about what you get when you put these two guys together inside the square root? Right, well, we're, I don't know, halfway through. Now that's pretty much done. There's an x cubed, and there's a y squared. That's going to be that fella. And now I'm breaking them all apart again. After putting them together, kind of seems like you're doing more work than's necessary, but you have to do it this way. You break them apart. Okay, let's take this guy. The square root of x cubed. Right. What does he get you? Square root of x cubed.
X times square root of x.
Agreed? And, oh, isn't the square root of y squared kind of nice? Why? Tell you what, I'm going to stop putting absolute values around these guys and just assume that they're there. How about that? You know, yeah. We're going to allow you to do it in the final. I might as well just get that done here. Now, what about this fella? 4. Square root of x to the 5. That does come out of something, doesn't it? X to the 5. Any ideas?
X squared is the square root of x.
Yes, well done. I was about to. I think I'll still do it because not everyone looks like they're comfortable with that. That's how you split it. And this piece gets you the x squared, and this little piece is just left over. Right, so that's where that came from. Oh, that's a good one. Isn't the square root of y to 4 a nice thing? Tidying up, not an awful lot here. 6xy square root of x, 4x squared y, square root of x. Now here's a temptation that you have to kind of control. Isn't there a real big temptation to add these together and make 10 or something? And the reason why I think that temptation might be there is, don't they all have square root of x's in them? Don't they all have a y in them? Don't they all have some kind of x in them? And they all have a number in them? Do you know, if it wasn't for the fact that that was x and that was x squared, wouldn't these be like terms and I could add them together and get 10 stuff? But won't that x and that x squared kind of kill that process? They look the same, but they are not. Which means we're okay. So that's distributive loss. I'm going to do some FOILs. Well, that's not good. It's saying my interconnection is unstable. Is my voice coming through okay?
You're cutting out sometimes.
Yeah. Okay. Right now, is it okay?
It's stabled out.
Okay. I think we all from time to time, don't we suffer from dodgy connections? I have got cable, and I've bought pretty much the best package you can because of my job. So I should get my money back if I've got an unstable connection. I can understand that some of you are in the middle of nowhere, but I don't live there. Okay, this is going to be a FOIL. 3 square root of x plus 2 square root of y. 3 square root of x, take away 2 square root of y. Agree that's a FOIL, right? 2 things times 2 more things. I'll do my little arrow here, just like we did with the numbers. If you do the F, you're going to multiply 3 root x times another 3 root x, and won't that become 9 the square root of x squared? If I then do the outside, the O, I will get negative because a positive and a negative thing. I'll have a 3 root x being multiplied by a 2 square root of y, and I put them together, I get negative 6 the square root of xy. Right, the 2 numbers get you 6, and these just become that. If I then go the inside, I get 2 in this guy, so what do I get? I get positive 2 square root of y times 3 square root of x, and that gets me positive 6 square root of xy. Interesting. And then if I do last, I get negative 2 square root of y times 2 square root of y, negative 4 the square root of y squared. Do you notice anything interesting about 2 of these terms?
They cancel out.
They do, don't they? Which means that this guy here and this guy here are the only 2 that's left, and they come out to be quite nice as well. Isn't the square root of x squared 3x? And the square root of this guy, well, what am I saying 3x? 9 is still 9, 9x. And this guy here is take away 4y. Now, as long as I pretend that x and y are greater than 0, do you know I don't need absolute values? So that's my excuse for why I'm not using them. I'm just assuming x and y are positive. That might be what the book was doing when it did that. Can you combine these 2 guys together and get, I don't know, 5 somethings? Or is that as good as that gets? As good as it gets? Okay, agreed. Let's try x root x plus 2 square root of xy. Square root of xy plus 2x. Now that is one ugly FOIL. You agree? That ain't going to be pretty. But we can do it. I'll just do a point in this time. If you do this guy times this guy, you're going to get x root x times the square root of xy, which is going to get you x, the square root of x squared y. If you do these 2 together, you're going to get positive x root x times a 2x, and when you combine these, you're going to get 2x squared square root of x. If you do this guy times this guy, you're going to get 2 square root of xy's times another square root of xy, and that's going to get you x squared y squared. And then if you do the last fellas, you're going to get 2 square root of xy times 2x, and that's going to get me 4x the square root of xy. Yep, ugly. Okay, we're now going to go through each piece and see what we can do to make it simpler. You split it into its pieces, you get that. And would you agree the square of x squared comes out quite nicely? Won't you get an x out of that? square root of x squared is x. And if that x gets multiplied by this one, are you happy about the square roots just disappear and you get x squared y now? You've got x squared square root of y now. Can I do anything to this mess? So I guess if you can't do anything, you don't do anything. Oh, let's go for glory here. I want to simplify two lots of the square root of x squared y squared, right? The 2's there. Doesn't this come out really nice? An x followed by a y. Agreed? Is there anything you can do with this last one? And that is pretty much it. Would you agree each one of these terms is different enough from the others that you can't combine them? So you're finished. Is there anything that I've done so far to do with multiplying basically square roots that you'd like me to talk about or we feel good? Last chance, we feel good? Okay. I'm now going to jump over to our homework. Hopefully I've got it set up. If not, I'll make sure it is set up. And right. And we're going to just look at the multiplication and the square roots because we still have the others, half of that to do later, which is cube roots. I'll say can you all see the homework from 7.4? No. Okay. Go out. Do a share. Go basic. Go. I need a new pair of eyes here. Can you see it now? Okay. So these are the types of questions that you're going to basically do. Don't worry about 2. I'm going to show you how to divide later, right? We're only concentrating on multiply. So some of these questions I'm going to skip by until we've done them. Do you know if you want to multiply this out, you don't even get to do it. You just have to remember it's called the distributive property. If you've got a single thing times brackets, it's called that. If I gave you 2 brackets, wouldn't it probably have a little pull down that you'd say use FOIL? So it's not asking you to do the question, it's just asking you to describe, I guess, what kind of question it is, right? So this is a distributive question. Well, that's what we call it when you have one thing outside the brackets and 2 or more inside. Would you agree that quite a lot of these questions, hopefully you agree with me, are not too bad? If I was going to do question 3, wouldn't I multiply them together and get the square root of 45 and then simplify? What, 2 lines? Done. Wouldn't that be the square root of 12 first and then simplify second? Done. That 8 will just have to live for a little while, but won't you go 6 times 12 and get 72? So it would be 8 times the square root of 72. And then you simplify the square root of 72. Okay, this is memory work. Square root of 72, how are you going to split that? Something times something gets you 72. It's in the list. Well, you can't see the list, but it is in the perfect square list. 72.
9 and 8.
Say again?
9 and 8.
Okay. I think it might be my signal. You are very quiet, Mark. One last time.
9 and 8.
Good grief, you're now very loud. Oh, my computer's been weird today. Yes, 9 times 8 is what he said. I can beat that. If we're having a game, you know, I can beat that. It's correct, but it's not perfect. There's a better version. What is it?
36 and 2.
36 and 2. Right? Now, if you had the list in front of you, start at the biggest number and work your way up, and the first one you meet is the one you should use. So if you got my list, although you can't see I'm talking as I do this, you get to 49, that doesn't work. Then you get to 36, and you say, oh yeah, 36 times 2. If you just do it by memory, it's great that you can do that, and a lot of the times isn't it going to be the right answer? But sometimes you don't quite get the answer. So if we did 9 times 8, right, that would have got us 3 times square root of 8. Right, so far so good. But if you think about it, can't the square root of 8 be called 4 times 2? So you probably would have got eventually the right answer. The analogy. Do you know sometimes when you simplify a fraction, you don't necessarily get the best answer right away? Like you divide the top and bottom by 4 and it's good, and then you say, oh yeah, but I can also do another 5. So it's not a bad thing that you can do that. It's a very good thing you can do that. But always be aware, just have another look in case there's more. Question 6 is the same question. The only difference is you pick the right answer. Let's see how good you are at doing your head. In my version of question 6, yours will be different, I'm pretty sure. In my question 6, what one of those 5 dots does that thing eventually become?
14 square root 2.
Do you agree with her? Well, check it out. Isn't 2 6s 12, and 12 gets you 2 root, well, gets you 4 times 3.
I think it should be square root 3, sorry.
Right. Check it now, right? 4 root 3. That's a cube root, forget it. Cube root, forget it. We haven't done cube roots yet, so I'm just zooming by cube roots. Question 11, can you see how that's just going to be multiplied together first and then make it look pretty later? We've covered that. When you get 54 as a number. And then when you combine these 2 square roots, oh, that's interesting. Do you know you end up with the square root of a squared b to the 4? Oh, but isn't a squared a really nice thing inside the square root? Because the square root of a squared just gets you an a. And won't the square root of b to the 4 get you a b squared? The software doesn't treat me as a student, unfortunately. So you tell me, if that was right, does it put a little green check mark and make you feel good? Or does it just tell you nothing and you don't know until you see your score? How does it normally work? Or it gives you a little check mark, again, let's put a thumbs up. So you get a kind of, you know it's right. And if it's wrong, what is it? It's a red cross then. And then you fix it, hopefully on the second shot, and then you've got one last shot to, if you don't get it. Okay, are we comfortable that these questions are very similar to the things I've been doing, right? Question 12 is just an uglier version. Would you agree that 13 is a distributive law like we did before? So 6 root 2 times 9 and 6 root 2 times this guy. 14 is another one. 15 is basically the same. I'm guessing, but at least half these questions just have numbers, don't they? So that makes life a lot easier than when you have variables. There's another distributive. Oh God, look at 18. Ooh, I do not like 18. I have -5, the square root of 7x, and in brackets 6 square root of 5x's, take away 6 root of 6. Right. I'm going to do that one once we leave this. But would you agree that is one ugly looking multiplication, right? Is that your dog wanting attention, Kaliana? Oh, that is such a beautiful color as well. Oh, and it likes the ears. It definitely likes the ears. Okay, so what number is that question? I forgot which one it is. Oh, it's 18. Right. 19 is even brutaler, but I'm not going to do that one. Oh, there's a FOIL. You see our first FOIL with numbers? There's our next FOIL with numbers. There's 3, there's 4, and our last FOIL with some letters. With the exception of question 18, which I'm going to come out and do with you, would you agree that we probably covered all the situations that you need to do that group of questions? Good. So I didn't like 18 and I didn't like 19, but I'm only going to go through one of them. So let's see what that one ends up looking like. Okay, I can't see a darn thing. Are we good? Can you see my white paper now? All right, so this horrible mess times that horrible mess. It's too much going on for me even attempt to do it in my head, especially at this late time of the night. I'm just going to write it down as a multiplication, and now I'll do it. Negative 30. 7x times 5x gets me 35x squared. Yep, it's ugly. And this guy times that guy. Well, 2 negatives make the answer positive, and it's going to be this ugly fella times that guy. 5 times 6 gets me 30, and square root of 7x times 6 gets me the square root of 42x. I think it lives up to its reputation of being a pretty downright ugly answer. Okay, negative 30 is fine. I'm going to split this up as a square root, of 35, followed by a square root of x squared. Plus 30 times the square root of 42, followed by the square root of x. Is there any combination that 35 works with? Because normally we would expect something, but there are some questions that you're right to shake your head. There isn't anything I can see. I should check and just, well, okay, let's suppose I wanted to do a check. 36 is silly, right? Is 25 times a number 35? No. Is 16 times the number 35? No. Is 9 times a number going to get me 35? Basically, is 35 in the 9 times table, right? That's what I'm saying. What was that said now?
I'm so sorry. I was talking to my mom.
Is your mum going to help with this question? Because if she is, she should go on and we should see her while she's doing it.
Absolutely not. She cannot do math. I'm sorry.
Okay, so can you see as I go through, nothing works? The bottom line is that that is as good as it's going to get. On the other hand, at least the square root of x squared becomes x. So I'm going to have negative 30x, and it's the normal convention is to stick the square root at the end. Right, maybe we'll get some more better luck this time. Is there a version of 42 that we can use? Do any of these play with 42? I can't see any. So, after spending all my time breaking that apart, aren't I just going to stick it back together again? Sometimes you don't know that nothing's going to happen until you focus on it. I guess if I focused here, I could say nothing's going to happen and write that down. I guess I could have done that. Last check. Are these two guys similar, in which case I can combine them, or are they different enough that I'll leave them alone? Different, agreed. We cool with the answers? So that's everything you need to know about multiplying square roots. Let's do the division square root. There's only one question. I just want to get it out of the way, right? Because you don't really do too much practice at that, but it is possible, and I want to show you how it works. The kind of version of the question I'm talking about is this version. So you might think, well, you can't really do nothing with it. Would you agree the square root of 5 is as good as the square root of 5 is ever going to be? And 4 is nice, right? So there's nothing I'm going to do to that. And you might superficially say, oh, okay, well, that's the end of the question. But there is a kind of style point rule that says when you have fractions, which this is essentially a fraction, you're not allowed to have a square root in the bottom if you can possibly avoid it. That's just the rules of the game. So all mathematicians in the world have agreed that fractions can't have square roots in the bottom. They're allowed to have square roots in the top because sometimes you can't avoid it, right? The numerator can have square roots, but not the denominator. So we use a rather clever trick. I'm going to multiply by a special version of 1. Wouldn't you agree that root 5 over root 5 is just the number 1? Well, let's see what happens here. Won't the top become 4 root 5, and won't the bottom now become 5? And we're finished for this one. So suppose we have 2 over the square root of 8. I'm going to use that trick, right? Now, if you multiply the top together, you get 2 root 8, and you multiply the bottom together, you get 8. Now, shouldn't we always simplify fractions and square roots until you can do no more? Right now, if I didn't worry about the square root of 8, couldn't I divide these two and get the square root of 8 over 4? Right? Top and bottom, right? 4. And sometimes that's me finished. You know, if that was the square root of 7 on the top, I'd be finished right now, right? But not always. Can you simplify the square root of 8? Four times 2. Square root of 8 is 4 times 2. Doesn't that make the square root of 8 become 2 root 2? And sometimes that's you finished. But not this time. Because can we do a little more cancelling? And this guy cancels with this guy. And your final can't do any more is that. This fella is that fella. But this is considered the simplified version of that guy. Technically speaking, I'm not really dividing, but they count it as dividing. You know, because I guess I've got a guy in the top divided by a guy in the bottom, right? But really, I would describe this more as simplifying something, right? Making it look nicer. And the rules of the game are that when you have a fraction, you make sure that the bottom isn't a square root, if you can possibly avoid it. In this case, root 2 over 2. Actually, I think root 2 over 2, I don't know if it's you, but for me, that does look nicer than that. Would you agree? Well, maybe you disagree. I think that looks nicer. It certainly gets smaller numbers. It's easier to deal with as well. That's pretty much us done as far as square roots are concerned. So I'm now going to move on and do cube roots. So let's just remind you, it's very similar skill set. So let's do a cube root of a number. Cube root, oh, let's not quite yet. If I'm going to do cube roots, don't I need perfect cubes? Because I'm going to work with these guys now, right? So there's 1, 8, 3 cubed is 27, 4 cubed is 64, and 5 cubes is 125. One of the few nice things about cube roots is, aren't there a lot fewer perfect cubes to worry about? So there's a lot fewer combinations that you need to deal with. So if I said to you, I'd like to know how to simplify the cube root of 54, don't you do the same kind of thing that you would do with square roots? You find a perfect cube times something else that gives me 54. In this question here, do you see 27 does it? So if you do 27 times 2, you can then separate it into the cube root of 27, followed by the cube root of 2, and that guy is 3. And there's your final answer. So it's got much the same kind of process as we would do with square roots, doesn't it? But now it's perfect cube times something rather than perfect square times something. And as I said earlier, there are a lot less choices. So it should be easier to tell when you can do it and when you can't. Give an example. Cube root of 33. Agree it ain't going to happen. That's as good as it's going to get. Cube root of 32, on the other hand. You can simplify 32, can't you? Who do you get? Who's the two numbers that work well with 32?
Eight and 4.
Right. And then that gets you the cube root of 8, which is 2, cube root of 4. Let's put variables into it. The cube root of x cubed. That's a very special one, isn't it? It's like the square root of x squared. Don't you just get x? Gets a little bit messier when you do the other two. And really there is only 3 situations. The cube root of x to the 4, and then a slightly different looking answer, the cube root of x to the 5. If you want to simplify them, you think of them as x cubed times 1x. And for this one, you think it as x cubed times an x squared. And this simplifies out as an x cube root of x. And this one simplifies out as an x cube root of x squared. And basically every cube root will either work out perfectly, right? No more cube roots left. Or you'll have one x left over, or you might have 2 x's left over, right? An x squared. So far, so good? Right. So we're going to go through a similar group of questions that we did. First, we'll do it with numbers. Right. Distributive law, you know, a FOIL, probably not anywhere near as many. And then we'll stick in variables, distributive law, and so on. So, suppose you have the cube root of 2, and you multiply it by the cube root of 4, take away the cube root of 16. So this would be an example of the distributive rule, right? The distributive law. The cube root of 2 multiplied by the cube root of 4 gets you the cube root of 8. A lot of people don't need that line. Maybe you're one of them. Could you go from there to there and feel comfortable? Then you should do it. Now, take away, it's going to be a cube root of 2 multiplied by the cube root of 16, which gets you the cube root of 32. Do you see we're doing exactly the same thing as square roots? Don't you put them together first and simplify later? Right, so you get two things coming together as a single cube root in this case, and then you take the single cube root and you figure out if it's possible to make it look pretty. I like the cube root of 8, because isn't the cube root of 8 one of those really nice numbers like the square root of 25? You get 2. Is there anything you can do about 32? is there a guy over here that'll work with 32?
8 and 4.
Okay. Which means that you'll get the cube root of 8, which is 2, and a leftover cube root of 4. And I think it's pretty obvious that those two guys are different enough that you can't combine them, so you're finished. Are we comfortable about distributive laws that involve numbers, cube roots in particular? Okay, so next guy I'm going to do is cube roots in a FOIL. Now I'm making the assumption here that we're comfortable with this, that's why I'm not doing like 2 or 3 examples. If you feel that you need to see more, then this is your, could we do one more of this, and I'm more than happy to help. So do you want me to do another distributive one, or do you feel you're comfortable with the process? I'm not very good at mind reading. I ask my wife, she'll tell me I'm not even very good at listening. That's a totally different skill set, but I'm certainly hopeless at mind reading. So
I feel comfortable.
that's the kind of feedback I need. Nods will do, right? I know it's late in the day and I bug the heck out of you, but I just don't want to go and you're not getting it, because I really want you to be successful. And I could quite easily just say, well, nobody's saying anything, it's going great. And then, you hit the homework and you crash and burn, and, you get really depressed and so forth. So here goes. Cube root of 2 plus the cube root of 8, why not? Cube root of 32, take away cube root of 27. You recognize a FOIL. So that guy first, that guy second, right? That guy third, that guy last. So we've got first, outer, inner, and last. This guy times this guy. If you multiply the cube root of 2 with the cube root of 32, you get the cube root of 64, right? It's that one. The cube root of 2 times this guy is negative. So the cube root of 2 times the cube root of 27 gets us the cube root of 54. Okay. Inside, cube root of 8 times this guy. Cube root of 8 times, it looks like my dog wants a poo walk, 32. I wish I'd thought about this question before I put down the numbers. 256. That's interesting. And I guess I need some room over here because I didn't plan ahead. The last one is going to be, it's going to be negative because of positive and a negative, and it's going to be the cube root of 8 times the cube root of 27, and that's what calculators are for. So 8 times 27 is 216. Wow, did I give myself a hard time? But I guess if you can do the hard ones right, you can do the easy ones. So here are the 4 guys that we got from FOIL, right? That came from F, O, I, and L. Each one of them, we are now going to work on them. And I think I'm going to have to move up the food chain here. Do I? Yeah, that's 5 cubed. If you do 6 cubed, you get 216, okay. Just in case we needed it. Right, here we go. 64 is the only decent one I managed to come up with. Would you agree the cube root of 64 is a perfect number? What number is the cube root of 64?
4.
Great. Would you agree that 54 can be written as 2 times 27? Right, or 27 times 2 if you want that. So although you probably don't need this, since this is like notes that you might want to look back at, That's going to get me a cube root of 27, so it's going to get me 3 cube root of 2, right? That's what that gets. You might not need that line, but that's what you get. I'm looking at 256. Oh, got it. You can use one of the perfect cubes on 256. I didn't know that was going to happen because I don't like big numbers, right? But this one works. Who works with 256? Which one of these works with it? Correct, 64. And 64 times 4. And that guy is a very nice number, isn't it? That guy is 4. So you get 4 cube roots of 4. Okay, it's getting there. Oh, cube root of 216. It's a perfect number. And it happens to be the perfect number, 6. 6 times 6 times 6. At least that's what my calculator told me. Yep. That guy, 6 cubed. Which means that we can take this guy and this guy. I guess we'll call the answer -2. And then I have that fella plus that fella. And I'm pretty sure that none of them even vaguely look like each other, so I'm finished. We're comfortable with the numbers? Feel good? Do I need to give you some examples of them, or do you want to just move on? We're good without examples? Okay. So all I'm going to do now is a couple of examples with X's and Y's in them. If they go well, we'll have a look at the homework and we'll show you that we've pretty much, we've covered that, and that's one of our 2 sections for the night finished. So we're halfway there. So, cube root of xy squared multiplied by cube root of x squared y, take away 2 lots of the cube root of x cubed y to the 4. So I'm not hanging back here, right? I'm getting stuck in with the really ugly ones right away. Now, according to the distributive law, this times this, take away this times this. So these 2 first. If you multiply the cube root of xy squared with the cube root of x squared y, and you put them together into a single cube root, don't you get x and x squared, x cubed, and y squared and y cubed? Great. Now, negative. If you take the first guy and you multiply him by the second guy, what do we get? We get as a single cube root, this guy times this guy is x to the 4, and this guy times this guy is y to the 7. And I forgot there's a 2 there. So I found it. So far, so good? Right, last step. Don't we have to simplify these guys and call it good?
I guess I'm confused. Why is that y to the 7?
Okay, if you take y cubed and you multiply it by y to the 4, the rules are that you add the powers. And so you get 7.
Shouldn't that be y squared, though, from the beginning of the problem?
I thought it was y to the 4. Here. Oh, did I write something weird down? Oh, I see what I'm. Didn't that square, for some weird reason I can't tell you because I don't know why, turn into a cube?
Yeah.
That it was a mistake. That's what that was.
Okay.
So, won't a square and a 4 get you a 6?
Okay.
Right.
Yes.
That was just me being careless. Right. We good now? So, I don't know why I put that symbol there. I've just realized something nice is going on, but I guess I'll do the working anyway. You typically wouldn't write all these lines. Won't this split as two separate cube roots now? Except, look at how nice they are. The cube root of x cubed is x, and isn't the cube root of y cubed y? Do you see that came out as a really nice answer? So it has been worthwhile. I mean, if you look at what we started with, isn't that looking much nicer? Now, this fella is, ooh, he's not so pretty. It's going to split as the cube root of x to the 4 with a cube root of y to the 6. Okay. I'm going to do it kind of back to front. Would you agree the cube root of y to the 6 is quite nice? Right, the cube root of y to the 6, doesn't that come out really nicely? What power of y does that come out? Because it's a perfect fit. Great, y squared. Yikes. Okay, I might do this over here. I need to try and simplify that guy. Don't we call it x cubed times x, which is the cube root of x cubed times the cube root of x. And that gets you x cube root of x. That's kind of what I would probably have done in my head. Now this guy looks quite nice. If I rearrange these guys a little bit, we got that. And these don't play well together, so we're finished. So that would be a distributive law, right? With x's and y's and all sorts of ugly pairs. Okay. You want to see another one of those, or are you comfortable with one? Get nods, so I'm using that as my guide. Right. FOIL. Let's look at FOIL. The cube root of 2x y squared plus the cube root of y multiplied by the cube root of 4 x squared y to the 4, take away the cube root of y squared. I mean, ridiculously ugly, right? Can't think of anything. Well, I guess I could have stuck a 3 or a 2 in it, but there's not much more I could do to that, right? It's pretty much the worst case scenario where there's horrible bits everywhere. Now, it is a FOIL, so we're going to go first, outside, inside, and last, right? The cube root of 2xy squared gets multiplied by the cube root of 4x squared y to the 4. And it looks like I'm going to need to go all the way over here. This guy times this guy is next, so it's negative the cube root of 2xy squared multiplied by the cube root of y squared. If you do the inside, you're going to get plus, and it's going to be plus the cube root of y times the cube root of 4x squared y to the 4. And then the last is negative the cube root of y times the cube root of y squared. Whoa, that is ugly and long now. Now let's put the pieces together. If you take this guy and this guy, you get 8. This guy and this guy, you get x cubed. And this guy and this guy, you get y to the 6. So that's those terms taken care of. Next cube root. 2, that guy and that guy. Well, the 2 is still there, the x is still there, but I guess you get what, y to the 4? This y squared times that y squared. Plus This fella times this fella, what does that get as well? We get a y times all of this, so you're going to get a 4x squared y to the 5. And then lastly, you're going to get negative the cube root. And if you multiply this guy and that guy together, you get y cubed. So we have 4 different cube roots that are all going to get simplified. And let's see what we get. I like this one. It's made up of 3 bits, but aren't the 3 bits, don't they play really well with the cube root world? That guy is a 2, because the cube root of 8 is 2. Isn't that guy an x, because the cube root of x cubed is x? Isn't that guy a y squared? So that one came out nice. On the other hand, not so much luck with this one. Would you agree the 2 is not going to change and the x is not going to change, right? If I focus then on the cube root of y to the 4, would you agree the cube root of y to the 4 can be fixed? If I do, it's kind of working over here. The cube root of y to the 4 can be called the cube root of y cubed times the leftover y, and that is going to be this fella. So this guy here is a y cube root of y. Let's look at this one. Can you do anything with the 4? Yeah. You can't even do anything with the x squared. Agreed, the cube root of x squared is kind of stuck. So I'm just going to leave those 2 guys alone. Can I fix the cube root of y to the 5? Well, it's almost the same kind of question as y to the 4. The only difference is, won't there be a y squared left over? So you end up with y, the cube root of y squared. And then I guess it's a consolation prize. Would you agree that this guy is a nice one? And you get what? Negative y. Hey, it now fits on the same piece of paper. Let's tidy it up as best we can. You're pretty cool. That guy and these 2 guys, you're going to get a y cubed, and then everything else, the 2x and y go inside a single cube root. This guy here, what you're going to have a y, and then everything else goes inside a single cube root. Take away y. And none of them play well together. I can imagine that that's going to be quite hard if you've got a question like that to type into your WebAssign. Does the WebAssign box get bigger if the answer's really long? Or does it disappear off the edge? Gets bigger? Okay, so it would just increase in size to fit an answer that looked like that. Well, I'm just going to spend a few moments. I've lost my thing. Where are you? Oh, here we are. I'm going to spend just a few moments going over the homework and just talking about what we see, and then it's time for a break. Okay, well, I'm just going to wind back now to the stuff we missed. Can you see that the square root of 5 then is basically they're just telling you what do you call those guys, and that process is called Rashomons. We've done all the square stuff. Right, can you imagine question 8 now is just multiplying 2 cubes roots together and then seeing what you can get? Multiply, make it look pretty. Multiply, wow. Oh, good luck with question 10. Isn't that going to be a massive number? But it's going to work. I know it's going to simplify. Oh, that's me from last time. I wondered what that's gone to. I think our cube roots are almost over with. If not, we're finished. So not too much in the cube root world, right? mostly square roots. And I think we all deserve a little break, don't we? So off you go, have a 10-minute break. I'll see you back here around about 6:34 if you want to be precise. And we'll move on to our second section once you come back. Okay. So how are things, Mark? You having a okay time right now? We're not stressing you out too much? Oh, he's gone. I might have stressed him out. You're back. I didn't stress you out that much. You have to hit the space bar if you want to talk.
Okay, there we go. My computer's just being slow with Zoom today.
Uh,
No, I mean this is like the one thing in math I'm actually like really good at for no apparent reason.
well, if you're going to be good at something, algebra is a good thing to be good at. Right. And calculators can take care of the arithmetic stuff, right? So even if you're not that great at arithmetic, the calculator will save you. Oh, you're back, McKenna. We got a picture of you now. It is nice to see you. You're not stressing out. We're on a break here, so I'm just chatting because I can.
I've been here, just like
Doing
interesting.
your thing. I hear you. Does anybody, since we're having just a general conversation, does anybody want to know something about Scotland? Since I'm homesick, it'd be nice to talk about it. That didn't work well. McKenna left.
I do.
Okay, what do you want to know, Hannah? Oh, you're back, McKenna. Well, while you're thinking, do you know Scotland's only got slightly more than 5 million people in it? It's quite a small country. So I don't know if you knew that, but that's essentially it. Scotland's got 2 languages. We speak almost exclusively English, or at least our dialect of it. But the second language is called Gaelic, and Gaelic is still spoken. It's really almost a dying language, unfortunately, and I'm a good example of it. I don't know really more than a few words of Gaelic. But the people who speak it like their first language, right, are typically way up in the Highlands in isolated villages, and especially over in the Western Isles. The Western Isles is the name we give to the islands to the west of Scotland. So if you look at a map of Scotland, you'll see a lot of little tiny islands, and they're tiny islands. I'm talking about some of those islands only have like 50 people on them, and everybody in the island can speak Gaelic.
Well, it was outlawed, wasn't it, for quite a long time?
Yeah.
About 100 years before World War I.
Jacobite rebellion is basically what happened. Yeah, the English have been trying to defeat us for a long time, and we eventually got anglicised, I guess is the word. That's why we speak English. Yeah, and they did all sorts of things. They forbid the wearing of the kilt, which is our traditional dress. They essentially outlawed the use of the Gaelic language. The usual kind of thing, you try and destroy a culture if you try and take it over. Not unlike what's happening right now. Yeah. If you want to take over America, first thing you got to do is destroy its culture, destroy its images, destroy its buildings, destroy everything you can. And then once it's all destroyed, you build it from new. Yeah, Scotland's quite homogeneous. It's not so much as it used to be. I'll give you an example. In my childhood, when we didn't have a car, so we didn't get around much. But in the places I lived and worked and walked around, 90+% of the people were Scottish, meaning that they were born in Scotland, their parents were born in Scotland, like me. Everybody was born in Scotland, right? They're just Scottish. And foreign people were quite rare. In the school, I was in a school and I taught in the school as well. In the school I started teaching in, there was only maybe, it was a big school of about 1,200 students. And of those 1,200 students, about 50 of them would be foreigners. And foreigners are English and Indian and Chinese, and anybody who ain't Scottish was a foreigner. And that's how few they were. The first black person that I ever met was actually at my school when I was a child. Right? Very rare. So the first black person I met was him, and his dad was a local doctor, and his mum was a nurse in one of the hospitals in Glasgow. And they came from Papua New Guinea. So you know, my experience of what a black person was that their parents were really well educated and rich. Because I went to a fancy school, not because I was rich. I went to a fancy school because be arrogant here. I was reasonably intelligent and got really good grades. So I got to go to a school for that reason. So yeah, that was my first impression. I thought all black people were rich and were doctors. You know, when you were really young, you kind of think the only people you meet, that's what everybody like that group was. Not saying that's not a bad stereotype, but it was a kind of unusual one from today. Different kind of life. Things have changed a lot now. It's kind of sad when I go back to Scotland. The foreigners have increased, and the foreigners are mostly East Europeans. For some reason, I couldn't tell you why. Our weather is horrible, but I guess if you're from Eastern Europe, it ain't that different. And I suspect that you know, in Eastern Europe there wasn't a lot of jobs, and evidently there was here, so people just came. And when we were part of the EEC, anybody from anywhere in Europe could move to any other part of Europe and get a job. So a lot of the Eastern Europeans moved there. But it has changed the culture a little bit as well. But that's life. Well, where are you from, Mark? I've spoken enough about me. Originally. I can't hear you.
Sorry, my Zoom is just being so. I'm from California originally.
Is that a family thing? Like your parents are Californians, or are you a kind of American where your parents were born in Kansas and you moved to California? You seem to move a lot in America.
My dad was actually born in the Azores.
The Azores?
Mm-hmm.
Oh, that's cool.
Yeah, so I'm 50% Portuguese on that side, and then my mom is like, she was born in New Jersey, but like her parents were born in Tennessee and Missouri.
Well, that's one of the things I love about America. That is such a cool thing. You probably know this, but not everybody who's listening knows this. Do you know do you know that South America doesn't just speak Spanish?
Mm-hmm. Speak Portuguese.
Brazil speaks Portuguese.
That's actually funny how it happened was the Pope at the time accidentally cut up South America and gave Spain all of South America, Central America, and accidentally North America because they drew the map incorrectly, and he gave it to them based off of a longitude line.
Oh, so the poor Portuguese got Brazil. Was that?
Well, they got which is the only reason they speak Portuguese.
Oh, okay. Yeah, I mean, it was. See, did you know that? Because a lot of people who don't know a lot of geography would have thought that all of South America spoke Spanish. But they don't. Do you know any Portuguese?
I don't know it. My dad is fluent, but he just never taught us.
Oh, that's a pity. I believe the Azores, I'm trying to imagine it, is an island or a group of islands to the northwest of Africa and west of Portugal. Is that pretty much where it is? Is it I think it's a fair old distance. Is it not like out in the middle of nowhere?
Oh, it's like almost the center of the Atlantic Ocean.
Right. So, yeah,
so
interesting.
If you were to go from like, you know, where Iceland is, Nova Scotia,
mm-hmm.
a little bit down into the east, it's right there.
Have you ever been?
No, I've never gone over there.
I think that's a kind of place I think I'd like to visit. Be kind of I like the sea and I like Ireland, so I think that would be cool.
Yeah, it's very temperate. It's a lot like Hawaii, just in the Atlantic.
Also, is Hawaii like 80 degrees all year round?
Mostly, yeah. And if it rains, it only rains for like an hour or two, and then it stops. Pretty interesting.
Yeah, that's not bad. Scotland's weather is definitely not like that. Yeah, Scotland's weather is very like here. We get about the same amount of rainfall as here. The only difference is, I would say, is our temperatures are about 10 degrees colder. So a good summer's day in Washington, and we had it in the last few days, isn't it? 90 something would be a really hot summer's day. In Scotland, a really hot summer's day would be 80s. You know, it's like 10 degrees colder. And in the winter, you don't get really that bad winters here, but you know, whatever your temperature is, if you knock 10 degrees off it, that's kind of what a Scottish winter's like. So we're colder all the way down. Although, since I lived 2 years in Alaska, I have experienced colder weather. Although I stayed in Southeast Alaska in a place called Ketchikan. That's where my wife came from. And that is a wet, wet place. I'll get these numbers wrong, but I think it has 186 inches of rain a year.
I've been there once for a little bit, but
Did it rain?
it was in the middle of like winter, so it was.
Oh God, so it snowed.
It wasn't actively snowing, but it was pretty cold.
Yeah, yeah. I think Ketchikan, I don't know the size, I can't tell you the size of it. When I lived there with my wife, I had a job as an adjunct professor for the University of Alaska, UAS, University of Alaska Southeast is its full title. That was one cold, wet place. True story, if you lived in Ketchikan during the summer, and you can guarantee that it's 4 days out of 5 it's going to rain. That's how bad it is, even in the summer. People who have little kids, you know, here if it pelts down, and it really does, it pelts down rain. It's not just rain, it's like buckets, it comes down. People here would keep their kids inside if it was a bad rainy day. If you did that in Ketchikan, none of the kids would see daylight. So what you see is that they dress, they're so cute. Do you know those little rubber Southwester type things that are all waterproof and big Wellingtons on? The kids, I was going, Wayne's, that's a Scottish name for kids. The kids go outside and they stomp about in the mud and the rain, and their parents have to let them. You wouldn't believe it if you looked at me and the fact that I've got one good eye, but I love to play football, soccer. And so I used to play soccer, and I was playing there, and they had a game on, and it bucketed down, and I thought, okay, the game's going to stop, right? No, they just play through the weather, right? They're just used to it. You know, the people who live there all the time don't really notice it so much, but if you've came from a place that didn't have that kind of rain, it kind of gets to you after a while. Okay, we are ready to get started. Is there any questions before I start? God, that goes away. We start on the second and final topic for today, which is going to be solving equations. Anything from the previous stuff? Are we good? We good, Evan? Right. I just noticed something that I'll have to do, so if you give me just, pardon me, a few seconds. That is not what I want. Do you know why I talk to myself so much? Anybody got any ideas?
I talk to myself because it helps me focus.
Oh, that's actually a sensible reason. I was going to say it's the only way I can have an intelligent conversation. Oh, come on, that's not bad, right? You don't get that one? So no, forget it. Okay, let's get started then. I was looking at something there that kind of distracted me, and that's why I kind of was half talking and half not. Right, let's look at, this is section, could have lost the numbers now. This is section 7, 5. Chapter 7, 5. Gotcha. And the topic is solving radical equations. Can you see my whiteboard, my white thing? Have I got the right thing on? Then why can't I move this? Oh, here we go. We're good. Right, I'm going to talk about these two terms, which are weird, and they're the only book I've seen that uses them, but I'll figure that out in a minute. Here is an example of a radical equation. You know what the job in equations is? Find out the x that's true for, isn't that how you solve all equations? Great. And there is a lovely technique called, because it's my name for it, as long as you do it to both sides, it's okay rule, that we are going to use a lot. Because when you solve equations, that's pretty much the go-to technique, right? Unless it's quadratics. So I'm going to look at this guy, and after doing various things to both sides, I'm going to end up probably around about here, writing down x equals 5, x equals 2, right? Whatever the solution is. And it's all about doing something to both sides, and it's all about doing it in the right order. So what's the first thing you should probably do to both sides in this question to get it closer to where I need it to be? I don't like square roots. I want it to go away. What could I do to both sides to make a square root go away?
Square it?
Yeah. So what you do is you square both sides. Now 3 squared is 9. And if you square a square root, do you see you basically, I guess the rule of radical equations is get rid of the radical as soon as you can. Does that make sense? You want to get rid of it as soon as you can. Because doesn't that equation now turn into something you could probably do, I don't know, when you were 10, right? Or 12 maybe. Isn't that just a normal linear equation? Great. So, what should I do next to both sides?
Take away 5.
Okay. And then shouldn't you divide both sides? And there, we've solved our first radical equation. Now, here is something that never typically happens in normal equations, right? When you solve a quadratic or when you solve a linear or a rational or any equation, normally when you get the answer, the solution, it works, right? That's why we did it, right? We're trying to find it. It isn't always going to be the case that all solutions work. So you have to check them, which is something you wouldn't typically do unless you had plenty of time. So to remind you what the original question looked like, it looked like that, right? So if x is 2, shouldn't that be 2 lots of 2, which is 4? And that becomes a square root of 9. And would you agree that the square root of 9 is 3? And wouldn't you agree that the check works? That means we're good to go. I believe for some unknown reason, when it works, it's called, and it's the only textbook I know that calls it that, they're going to call it not extraneous. So what's going to happen is you're going to solve equations and you're going to write down x equals 2, and then beside it, you're going to call it extraneous or not extraneous. Can you imagine that we plugged this in, but it didn't work? And I'm going to find one that doesn't work to show you it happening, right? So you got the equation x equals 2, you plugged it in and it failed, right? It didn't get you the answer. Then when that happens, you're going to call it extraneous. So the solution is still x equals 2, but extraneous. I don't like the extraneous or not extraneous. They're words that don't really mean a lot to me, and I'm pretty sure that's what they mean. I would probably prefer it works and it doesn't work. At least that would tell me what the heck it is, right? We have a really cool name for them, at least back in Scotland. Do you know the ones that don't work? We call them phantom solutions. Yeah, this is not a phantom, right? This works, right? But can you imagine, I'm going to try and find one right away as quick as I can, an example of at least one of them not working. I think phantom solution is just a better name. Doesn't it give you the idea that it's not, it's like a ghost that's not really there or not really usable? So finding one is going to be the challenge. So give me a second to see if I can figure one out. Darn it, it's not easy off the top of my head. I know what I can do. Hold off a second. I'm going to go in and pick a question from the homework, because I should be able to find one in that list that doesn't work, and therefore I can show you one of these guys. If I tried to do one right off the top of my head, I'd be able to do one, but I bet you I'd probably do one that works. Right? It's kind of hard to do one that doesn't work. So I'm seeing if we can. Okay, we got one. Yeah, that's too hard, but I can certainly do that later. I may have to do it earlier. Okay. The square root of 2x plus 7 equals 5. Right, let's have a look at that one. Are we still on the white screen? Can you see this? Okay, so why can't I see it on my screen? Where the heck are you hiding? Right, I'm going to have to just close it and go back in again so I can see it. Right, here is a radical equation. Any equation that has a square root in it, or a cube root. Right, let's try it out. I know I want to get rid of that square root, but sometimes you can't do it first, right? You have to do other things. Would you agree the first job is to get rid of that 7? Right? So if I want rid of this 7, how about subtracting 7 from both sides? So far, so good? Now, typically, if you want to get rid of a square root and you're at the place where that's going to happen, don't you just square both sides? So you square both sides. Now, -2 squared, doesn't that mean -2 times another -2? Doesn't that get you 4? And what's the square root of 2x squared going to get you? Doesn't it basically just get you 2x? Now, when I solve this, and by sheer coincidence, it's x equals 2, we have a solution, right? Let's check it to see if it works. Well, the square root of 2x plus 7 should equal 5, right? The square root of 2 times 2, which is 4, plus 7 should equal 5. Wait a minute, isn't the square root of 4 2? And 2 add 7 is definitely not 5. It fails. Was that a shock or a surprise that you solved the thing perfectly correctly, right? Doing all the usual things that you're meant to do, and we did get a solution. It's just a phantom solution, right? One that doesn't work. Have I convinced you then that you need to check your answers? because it looks totally fine. Because every question, at least everyone after about the first 5 questions, has a little box beside it where you have to say extraneous or not extraneous. And if it fails, oops, you'll call it extraneous. Or it doesn't work, right? Extraneous means it doesn't work. And not extraneous means it does work, right? Why the book didn't do that? Wouldn't that be a much easier thing to figure out? Because now you have to remember 2 words that don't mean anything. And isn't there a 50-50 chance that you'll call it extraneous when you meant to call it not extraneous? Because the 2 blooming words don't really mean anything to any normal human being. At least a phantom solution would be a nice name, right? At least it gives you an idea it's the ones that don't work. Are we cool? So, radical equations. There are lots of different kinds of them, so I'm going to try and do as many flavors as I can, different versions, and we'll solve them. And for each one, if there's 2 solutions, I'll check both. Can you imagine there could be a situation where one of them works and one of them doesn't? Right, that could happen. Can you imagine there's 2 solutions and both of them work? 2 solutions and none of them work, right? Anything is possible. Let's kind of begin back at the beginning. And we'll do a nice one, and then I'll just get progressively uglier, right? Okay, this fella here. What you going to do first?
Subtract the 2.
Okay, so we're going to be looking at this fella. Would you agree that you would square both sides next? Right, 3 squared is not 6. 3 squared is 3 times 3, right? It's 9. Subtract 3 from both sides. Hey, at least we got an answer that's not 2. Okay, we got a solution. Is it going to work? Not extraneous. Is it going to fail? Extraneous. Well, I should be able to try it in my head. I'm going to try it in my head this time so I can save myself some time. Right, 2 times 3 is 6. 6 add 3 is 9. The square root of 9 is 3. 3 add 2 equals 5. This one works, right? And that's called not extraneous, right? So far, so good. Let's try this fella. Let's do 2 radicals. As long as you do it to both sides, it's okay, Ro. Let's start doing something to both sides. What do you think would be a good idea here? Because there's not a lot to do, right? What would you do to both sides here? Agreed, square them. Now, if you square them, doesn't that happen? Now, from this point onwards, would you agree it's a pretty standard, relatively straightforward question? How about, because I want to, subtract 1 from both sides? And couldn't I then subtract 5x from both sides? And then couldn't I divide and get this guy? Okay, so I've only one solution. I think the next question I'm going to do one that has 2 solutions, but right now I've got 1 solution. So far, so good. We should check it, shouldn't we? The square root of 3 lots of -3 add 1. Well, that's going to get me the square root of 8 add 1, and that's going to get me the square root of 7. Now you might say, well, that's a complex number, and I totally agree. But we are going to make a big assumption these equations, we are only looking for real numbers, right? Normal numbers like 5.5 and 2 and -5. Isn't this not a real number? And not real means it fails. Now, I don't care if this side ends up also being the square root of -7. It just means it fails twice, right? So when you're doing your check, the left-hand side needs to equal the right-hand side. And secondly, nothing is allowed to be the square root of a negative number. The minute one side or both of them or the other side, the minute you see a negative square root inside it, that means that this angle, this answer, the solution, is extraneous. And that's because it fails, right? You can't use it. We good? Right, let's try one that has two solutions. Okay, very similar to the one on the left, isn't it? Aren't I just going to square both sides? Now that's going to get me x squared plus 4x, and that's going to get me 2x squared, take away 6x. Can you see that this is a quadratic, right? It's got x squared in it, so we have a different strategy for this. When you do quadratic, shouldn't you make everything equal 0? Right, so get rid of everything on one side. I'm going to get rid of the x squared first by subtracting it from both sides. I'm then going to get rid of the 4x next by subtracting it from both sides. So if you have to solve a quadratic, well, you try and make it x squared, so many x's, a number equals 0. Now at this point here, shouldn't we be factoring it to solve it? Would you agree that there's a common factor of x and the other factor is x minus 10? So there is indeed two solutions. One of them is x equals 0 and the other one is x equals 10. I think in the homework they call one of them the big answer and one of them the small answer, right? So that would be the small answer, that would be the big answer, right? I should check them, shouldn't we? Let's check the 0 one. Would you agree if you put 0 in here, that's nothing squared plus 4 lots of nothing? Don't you get the square root of nothing, which is nothing? And if you stick it in here, don't you get a whole load of nothings and the square root of nothing is nothing? Yay, it works. So x equals 0 is a solution, and it's a solution that works. And so you're going to call it not extraneous. What about x equals 10? Maybe it'll work as well, right? Maybe it won't. The square root of 10 squared plus 4 lots of 10 is the square root of 140. And on this side, it's 2 lots of 10 squared, take away 6 lots of 10, which is 200 take away. It's the square root of 140. And so we have got two guys that both work. So there's a solution, or there's a situation where there are two solutions and both of them are good, right? Both of them are not extraneous. Any questions so far? Okay. So let's try this fella. Yeah. It's kind of hard to do on the fly. Let's see. One quick check here. Gotcha. Okay. A little bit uglier, right? Only one square root, the other guy isn't. Any suggestions for what to do to both sides? Hold on a minute. My dog was scratching at the door, so she obviously wants in to join us. There you go. Right, any suggestions? What should I do to both sides to get this closer to the solution? You'll have to hit spacebar, I can't hear you, Matt. I still can't hear you.
Square them.
Okay. Yeah, okay. Square them works. Oh, now, won't this guy just become 3x plus 13? What do you think is going to happen to the 2? It's the first time we've seen this. Will it still be 2 or will it be 4? Be 4. Right? Everybody gets squared, right? That gets squared, that gets squared, that gets squared. Pretty much hasn't this question stopped being a radical and has turned into something different now? Now, if you FOIL this guy out, you'll get 4x squared. Then you'll get 8x plus 4. If you multiply this out, you get 12x plus 52. So far, so good. Since this is a quadratic, which is the most likely complicated version you're going to see, right? A quadratic. Won't we subtract 12x from both sides and then subtract 52 from both sides so that we get 0 on one side? So if you subtract 12x from both sides, you get that. And if you subtract 50, so you're going to have the usual problem of factoring. Have you seen that factoring just never seems to go away? It pops up all over the place. I think I can do something to this particular quadratic just to make my life a little bit easier in the factoring world. Can you see anything I might be able to do here? I hear lips moving and it sounded like divided by 4. Is that what you said? She's nodding, so we're going for it. You divide everybody by 4, right? As long as you do it to both sides. Now, would you agree that's a much easier quadratic to factor and solve for than the horrible 4x squared that we had a minute ago? Now, two numbers multiply together give me negative 12, and when I add them together, the same two numbers give me negative 1. Would you agree there's only one combination out there that does both those things? Agreed? So what combination of negative 12 should I be using?
Negative 4 and 3.
Agreed? And this fella tells me that x could be negative 3, so there's one of my solutions. And this fella here tells me that x could equal 4. So we have two solutions to deal with, agreed? Two distinct solutions. And they should, hopefully, both work. So my next phase would be, shouldn't I be plugging negative 3 in here and seeing whether the answers work? So let's check it out. This is me doing the check on x equals negative 3. Two lots of negative 3 add 2. Negative 6 add 2 gets me negative 4. That doesn't look too promising. 3 lots of negative 3 add 13. What's that? Negative 9. So 2 lots of square root of 4. 2 times 2 is 4. Didn't make it, did it? One side says it should be -4, the other side comes out as +4, right? So, extraneous, right, fails. Do you think the next one's going to work? Do you think if I did the same check on x = 4, it's going to work? Not sure? I guess that's why we
Yes.
have to, yeah.
It will.
Oh, you've beat me to it. Yes.
I did it on my calculator.
Yeah, it works, right? Which is what calculators are for, aren't they, really? I mean, if you're doing a messy calculation, I'm just writing this down so you can see the process. But I can imagine, wouldn't you just go to your calculator, 2 times -3, add 2, and write down the number or remember it, and then you do this one in your calculator and you say, wait a minute, different answers, it fails. Or, hey, they're both the same answer, it works. Right, that's pretty much it. Yeah, so we'll just call that checked. That one works, right? So it's called not extraneous. Are we getting more comfortable with the fact that when you solve radical equations, some questions have solutions that don't work, and that we have to check all of them, or else you won't be able to tell which one works and which one doesn't work? Okay, I'm going to give you one of these guys because I think that's going to be a good test. And then we're going to look at the homework questions to show you the square root ones. And then I'll return and I'll do the cube ones. The cube root, by the way, the cube root ones, which are a little bit further ahead, do you know the cube root ones are really good? There are never going to be phantom solutions in cube root ones. So you don't need to check. I'm just telling you that, right? Square roots cause, you know, phantom solutions, right? Solutions that don't work. We seem to have lost someone. Hey, we seem to have lost 2 people. Not McKenna's here. Who have we lost? Kellyanna. Where's she gone? Oh, there you are. You're moving around a lot, young lady. Okay, here goes.
My dogs are restless.
Oh, I know it. My dog here. This is true. She was scratching at the door, right? So I had to go and let her in. I let her in. She goes and sleeps. We don't have kennels. We have these kind of canvas things that look like tents, but they're for dogs. You know what she did? One scratch off me. She was happy. She went in there and she's snoring right now. That's it. She's an old lady. She's 14. She's half deaf and going blind. So you got to give her a little leeway when she gets kind of crabby. Okay, here's your guy. Oh, this is going to be fun. What am I going to do here? The square root of x squared plus 4. Is going to equal 2x. 2 of you have finished? Okay. We'll wait. Still a few minutes. Okay, let's get started. I gave you a good start. Would you agree the start is obvious? Square both sides. Right, so wasn't anything too messy here. So you get x squared plus 4, and you get 2x plus 12. Another quadratic, pretty common. If you subtract 2x from both sides, and you also subtract 12 from both sides, do you get that? This factors Actually quite nice factoring, isn't it? I believe you get -4 and +2. Am I good? Right. So there are two solutions, or at least candidates. That one and -2, right? So let's check x equals 4. 4 squared plus 4, 16 square root of 20. 2 lots of 4 add 12 square root of 20. It works, right? Not extraneous. Right, let's try the -2 guy. -2 squared add 4. -2 squared is 4, so 4 add 4, square root of 8. 2 times -2 add 12. Oh, square root of 8. Both of them work. So I could have, I guess, if I tried hard enough, I didn't know what this, I knew the solutions were coming out nice, you know, these. But what I didn't know is if any of them were phantom or not. You kind of really don't know until you check. Would you agree that especially negative x's, aren't they susceptible to being phantoms? They tend to generate bad answers. Positive ones tend to be a lot safer, right? They just are. So what I'm going to do now is we're going to look at the equations from your homework. Okay, and we'll talk you through some of the situations that I may not have covered so that you'll be able to do them. Okay, right now we're only going to focus on the square root ones. And once we've gone through these, we'll then go back and we'll do the cube root ones. You can kind of guesstimate, can't you, what's going to happen when I do cube roots? Isn't it going to have very similar algebra processes? But instead of squaring both sides, don't you just cube both sides? That's essentially the difference, the major difference, right? So this one you can do is 15. They should have, I guess, said, is x equals 15 a solution? And the answer is yes or no. Well, and the answers are here, so let's make them go away so we don't get confused, right? Are you happy about how you would approach question 2? When you just go straight into squaring both sides? And since they don't have this extraneous, not extraneous, I'm pretty sure whatever answer you get works. So you don't need to check it. Would you agree squaring both sides, it's going to work? That's fine. All right, here's the first guy where things are a little bit different. You see this guy here has a square root plus a equals a. Now, if I tried to square both sides right now, it would be a bad idea, trust me. Do you know what I'm going to do first is subtract 8 from both sides. Because won't that give me the square root of 2a minus 8? And then it equals, and on the right hand side, I'll have a take away 8. And I've just realized that unless you're a verbal learner, that might be too much to kind of take in. So I'm going to zoom out and write down what I just said so you can see it. So this is the question, right? This one here, that's an A, by the way. It looks, I don't know what it looks like, but what you do is you need a square root on its own. You cannot do a square root plus somebody or a square root take away somebody. If you square that, it doesn't come out the way you think it does. So you subtract 8 from both sides. And now you can square both sides. Now, do you know that you're going to have to FOIL this thing out? And then off you go. We're comfortable about how you would finish the question now that the hard part's over, right? FOIL that out, combine like terms, make it equal 0. You're going to get 2 possible solutions. Hopefully both work, but you can never be sure. Same thing's going to happen in question 5. Do you see that you're going to get rid of that 8 first by subtracting 8 from both sides? So just like the one I showed you a moment ago, subtract 8. Now, do you see they've got a guy, smaller value, larger value? So let's just pretend that the answers were -2 and 5, just for argument's sake, right? And you check them, and -2 worked, not extraneous. 5 didn't work, extraneous, right? You see that? No, doesn't work, does work, right? So let's get clear in our brains. Not extraneous means it works. Extraneous means it doesn't work. Okay, looking at question 6 then. What should I do to both sides before I start squaring? What should I do to both sides in question 6 before I start squaring both sides?
Add the t.
Yep. Isn't that the guy that's causing the trouble? If you're going to square both sides, make sure that the square root thing is on its own, right? It doesn't have a plus t or a -4 next to it. It's just a square root on its own. Because when you square that, won't the square root disappear? If you have a +1 or a -t and you square it too early, and trust me, if you do it correctly, it doesn't come out nice, right? It just doesn't. What would you do in question 7? What would you do to both sides first?
Subtract 7.
In fact, I'm getting deja vu. Is that not the one I did for you? Did I do that question? Probably did. Right, forget about the cube roots right now. We've done one like question 11. Won't you square both sides? Agreed? What's going to happen to that 9? Will it stay as a 9 or it will be 81? 81, agreed? Everybody gets squared. Right, now there's a little bit at the end which is called to change the subject, but let's not worry about that until we need to. So are we comfortable that you know the process for solving radical equations that have square roots, and that you sometimes have to check, well, not sometimes, you always should be checking, do the work or not? We feel good on that. McKenna's thumbs up, so that's a good sign, she's happy. I'm getting some nods. Okay, we're good? Okay. So now I'm going to have to show you cube roots. And the good news about cube roots, you don't need to check them. If you get a solution, it works. So that's something, right? So let's show you an easy one, then just kind of work our way up. There's 2 cube roots equal to each other. As long as you do it to both sides, it's okay, right? Would you agree that these guys are ready to get cubed? Both sides. And if you cube that one, you get this guy. And if you cube the other side, you get that guy. And hey, don't we just have a pretty much linear equation? Nothing too special. If you add 1 to both sides, and then you take away 5x from both sides, sorry about how ugly the answer is, you get that. And I don't need to check. I can guarantee it's going to work. I'm not even going to try and make nice questions happen because I just want to get right into the business of things. Let's try that one. Oops. Let's try that one, right? Cube root guy. As long as you do it to both sides, it's okay, works. Don't you just have to make sure you do it in the right order? Cubing both sides right now is not a good move, right? That's not going to help you. What should I do to both sides in this question first? I see subtract 5. It's cube root of 3x plus 1. If you subtract 5 from both sides, you get that. Where should we go next? What should I do to both sides next?
Divide by 2.
I would divide by 2 first. I got kind of lucky here. I didn't expect such nice numbers. At this point, isn't this the place where you now cube both sides? And this fellow just turns into 3x plus 1. Oh, by the way, 3 cubed is not 9. 3 cubed is 3 times 3 times 1 more 3. It's actually 27. So don't make a mistake there. It's a pity if you do all the hard stuff and then you get caught up on cubing 3. Now, how about taking away 1 from both sides and then dividing both sides by 3? And I don't care that it's a fraction. I know it's right, provided I count properly. And I don't even need to check it. I mean, that's a lot of pluses. Are we good? Right. Last one. Ooh, I'm going to have to wait a minute while I figure this out. Hide this. I want to make this one work nicely, because if I just write down random digits, you'll get 17 411s, and nobody wants that answer, right? So I'm going to just make something happen here. What am I going to make happen? Make x equals that. This guy, get rid of that. For a minute anyway. What's this going to be for? That's going to be 30. I hope I've counted this right. If I haven't, I apologise. Here goes. I think I'll just rewrite it again without all the rubbing out. Okay, tell me something to do to both sides. Got to do something. What do you want to do to both sides?
Divide by 2.
I would do that. Okay. Would you agree we've reached the point of no return where we can't do much except cube both sides? So if you cube this side, you get 2x squared plus 32. If you cube this guy, you get x squared plus 4. But don't you also have to cube the 2, which is 8? Agreed? Now distribute the 8. Oh God. No. I didn't realize that. It's still an answer. Can you see where this is going? Yeah. It's still correct, right? The answer I thought it was going to be, I screwed up somewhere. So anyway, let's go through the process. If you subtract 2x squared from both sides and you subtract 32, you get one of the easiest quadratics in the world to solve. Would you agree that x equals 0? Right. I thought x was 4, but evidently I screwed up somewhere. But the process is correct, right? So, you know, and it is the solution. It is the solution to that question. It's not like that's not correct. Maybe not a very satisfying answer, but it works. And I don't need to check it. So we're going to go back to our homework and we're going to look at some of these cube root guys, and then we're going to finish with what's called changing the subject of the formula. Whoa, okay. I can see one that I'm going to do for you in a minute, but let's not worry about it until we need to. Okay. Would you agree question 8 is pretty much ready to go? Won't you cube both sides and then solve? Cube both sides. So that's going to be 3n take away 7. That's going to be what, 8, and then you solve it from there. I believe the answer is 5. Would that one there, I'm going to write down. So I'm going to do, once we leave this screen, I'm going to show you how to do question 9. Because superficially it looks really easy, but it isn't. Now, once I show you how to do 9, you'll be able to do 10. There's just a little kink in 10. They've made things slightly weird. Do you see a third power? Isn't that just another way of saying the cube root? So it's really just question 9 again. So after I show you how to do 9, you'll be able to do 10. And we are pretty much done as far as those guys are concerned. So let's show you how to do 9, and then we'll look at what's called changing the subject, and we are finished. Oh, we'll be finished early, which is not a bad thing. First step, pretty straightforward, ends up ugly. Shouldn't you cube both sides? This is where the fun starts. I don't know if any of you have ever had to cube a function before. It depends, I guess, what kind of math you've done before. But we need to find out what b take away 3 cubed is. Now, we know what it means. It means this. The problem is, you've probably never had much experience, if any, of doing this. Would that be fair to say? You don't recollect it, or if you've done it, you've only seen it once. So let me show you how you approach this question, since it's a brand new question. You break it into chunks that you know how to do. Don't I know how to multiply b minus 3 times b minus 3, right? Forget that guy, but I know how to do that. You're going to have to trust me on this because I want to kind of move on. If you multiply this out doing the usual method of FOIL, can you trust me that you get that? It's easy to check. b minus 3 times b minus 3 gets you that. Now, there isn't a FOIL for this because it's 2 times 3, but there is a way to do it. B times the first guy, b times the second guy, b times the third guy. Then negative 3 times the first guy, negative 3 times the second guy, and negative 3 times the last guy. Do you see that's how you're going to approach this? So here goes. B times b squared, b cubed. B times this guy, negative 6b squared. B times this guy, 9b. Negative 3 times this guy, negative 3b squared. Negative 3 times negative 6 is 18b. And negative 3 times that guy is negative 27. Right? Now let's see what this does. Is there anything in here that you can combine together? Because I can see a couple. Is there anything here that can be joined together with the same kind of guy? for instance, who does that guy play well with? That guy. Agreed? So I have a b cubed because there's only one of them. I now combine these to get negative 9b squared. What about 9b and 18b? Can we combine them together? Yeah. 9b plus 18b gets me 27b. What about the poor number negative 27? Well, he's on his own, so you're stuck with him. So we now have b cubed take away 117 is equal to b cubed take away 9b squared plus 27b take away 27. As long as you do it to both sides, it's okay rule. Agreed? As long as you do it to both sides. So how about subtracting b cubed from both sides? I'm doing this one step at a time. Agreed? And couldn't I add 9b squared to both sides, subtract 27b from both sides, and add 27 to both sides? And if I do that, won't I get everybody together equals 0? So add 9b squared to both sides, subtract 27b from both sides, and add 27. So I'm now looking at 9b squared, take away 27b, take away 90 equals 0. Is there anything you can do to both sides that's going to make that easier to solve? I can see something.
Factor out a 9.
Okay, divide both sides by 9, factor out a 9. That works for me. You're now left with this guy. Okay. Two numbers multiplied together give you negative 10. When you add those same two numbers, you get negative 3. Who are we talking about? There's obviously a plus and a minus, right? Who are we talking about that makes that happen?
+2 minus 5.
Which means here are our two solutions, negative 2 and 5. Okay, you've probably never seen one in your life before, but now you have. And if you use this as your template, won't you be able to do question 10? So what's left? Well, not that much. It's called changing the subject of a formula. If you go to Canvas, you'll find I've got a PDF where I've got lots of examples of this. So you can get plenty of practice at just watching my situation. Right. So let's get you some notation. See if I tell you that V equals a half a t squared. That's a formula, right? You know, physics and chemistry are full of formulas, right? You plug A in here, you plug the number for T in there. And in this case, the guy that's on his own is called the subject to the formula. So in this particular formula, V is the subject, right? That's what we call it. Now, what you're going to do is you're going to take this formula and you're going to pick a different guy to be the subject to the formula. Let's suppose they want us to do A. So in other words, when I'm finished, it's going to be A equals. Right now it's V equals, but when I'm finished, it's going to be A equals. So we would say change the subject to the formula to A. And the book has its own way of doing that. And if you've never done this before, although, you know, sometimes they do it in physics. Don't you get a formula in physics and then they rearrange it and give you a new formula that does something else? They may not have told you, but do you know they're changing the subject to the formula when they do that? That's what that's called in math. Right, we're going to use my favourite, used it a lot tonight. As long as you do it to both sides, it's okay rule. Right? And I'm going to try and solve this like I was solving an equation. When you solve an equation, don't you want x equals whatever the number is? In this case, I'm going to solve it so when I'm finished, a equals whatever it is. And it's all about what you do to both sides and when you do it. So here goes. What would be a good move to get rid of that half? Because I think halves are really a pain in the butt. What could I do to both sides to get rid of it? You're moving your fingers, so I'm assuming you're saying times 2.
Multiply by 2.
Okay, so if you multiply it by 2, do you see it now turns into that? If you have two things multiplied together and you want to get rid of one of them, isn't the typical way that you do that is divide both sides by the thing? Now, normally it's divide both sides by 2 or 4, but you know you can do it with letters and variables. So wouldn't it make sense in this case to divide both sides? And there's your answer. And if you are a picture straightener like me, wouldn't you probably write it in the form A first and the letter sign, right? Right, same formula. But this time, the subject of the formula is going to be t. Okay, so I'm going to start by multiplying both sides by 2 because I think that's a good move. What do you think I should do next to try and get eventually the t on its own? But what should I do next first? Do you agree I have to get rid of the a? So what do you do to both sides to get rid of this? Divide, that's what I'm saying. Now, you're almost there. What do you think you need to do to both sides to get rid of a square? Square root? Okay. Is his butt right next to your face? He better not fart.
Oh, yeah.
If he is a farter, you better move.
She's not.
Okay. So t is the square root of tv over a, and since I'm a purist, I would write it that way around. Are you getting a feel for this is really just some special algebra where you take a formula and you rearrange it in terms of a different guy at the beginning? Right. So let's try a formula where little d is equal to the square root of x squared plus y squared. And we're being asked to change the formula to x. So right now the formula, the subject of the formula is t, and D like in Donald, but now we're going to make it an x. What do you want to do to both sides? I hear square, or at least I see lips moving that looks to me like square. Agreed? What should I do next? Oh, let's get some people in this game. Jessica, are you awake? Are you with us? I am going to see if the college can supply electrified chairs. And I'm going to say, Jessica, are you awake? And if she doesn't answer on the third one, I press this button and 240 volts shoots through her. Would the college frown upon that? Probably.
Probably, yeah.
Yeah. You know, they take the fun out of this job. It used to be so much more fun when you could throw things at students. You know, I'm not allowed to throw things anymore. Yeah. By the way, do you know I've only got one good eye and so my depth perception is shot? Right? Have you any idea how dangerous it would be in a class if I tried to throw anything at anybody? Do you know the safest person in the room would be the one I was trying to hit? Yeah, the poor soul sitting next to him has more chance of getting hit than that person would. Okay, I'll take a volunteer.
I'm so glad to be in an online class.
where you can't be hit. Okay, since you said something, you're definitely awake, McKenna. What do I do next in this question? I'm trying to get X on its own.
What did you just say? Sorry, I told you earlier my internet.
Okay, here we go then. We're looking at d squared equals x squared plus y squared, right? That's what we're looking on the screen. Hopefully you've got the screen in front of you. And I want to eventually get x on its own. And so my question is, what do I need to do to both sides to get closer to that place?
Subtract y squared.
I like your thinking. Does that kind of make sense? Okay, we're pretty much finished here. What do you think you do to both sides now?
Square root it.
Square root it. And we go. Right, I'll do two more of these and we'll call it good, right? So here's my second last one.
I have a question with that one. If you
Yes.
square rooted everything,
Yeah.
could the answer still be x equals d minus y?
Oh, I get what you're thinking. So you're thinking that you can take the square root to both of these and just call it d minus y, right?
Yeah.
It doesn't work that way, unfortunately. It only works when they're multiplied. It doesn't work when they're added or subtracted. Right, let me prove that to you. Can you pretend that we were going to do this calculation, right? This is an add, but it works for subtract as well. Now, right now, that guy, if this did work, wouldn't you call it 3 add 4, which is 7, right? If you were able to do a square root with adding, right, and separate them out as an add, if that was allowed, wouldn't the answer be 7? Well, isn't 3 squared 9 and 4 squared 16? And can you see that the answer is not 7? Do you see it just doesn't work? You are allowed to do multiplications, and they can separate out as 3 times 4, right? That's allowed. But not 2 things added or 2 things subtracted. Even if the things are nice, pretty squares, it's not allowed. But that was a good question, because that's actually a common mistake with some people, that you're in this mode of making it look nice, right? And so sometimes you have to know when you can't make it nice, right? That's as good as it's going to be. So W over 3 times AB. We're going to look at changing the subject when there's a fraction involved, and not just a fraction like 2 or 3, but a fraction where there's letters on the numerator and the denominator. And let's say that the question was change the subject to B. And I think I'll need more room, so I'm going to start up here. In questions that look like this, right, the formula is made up of a fraction with letters in the top and bottom. Do that. Call the guy on the left that. Can you see where I'm going to go next? It's called cross multiplication. And if you do cross multiplication, W times that, and these together get you 3AB. Do you see that the first job is to get rid of the fraction before you even focus on who the subject of the formula is? I don't care which one it is. Would you agree that that's the first job? Now I can focus on who do you want? Oh, you want this guy. If it was just 3, wouldn't you divide both sides by 3? If it was AB, wouldn't you divide both sides by A? If it was BP, wouldn't you divide both sides by P? Since it's all of them, shouldn't you just divide both sides by 3AP? You get it over with. And we're finished. Last one. Horrible fraction, That's our formula. And we want to change it so that it's in terms of x equals. Same situation as this one. Don't even worry about what letter you're trying to change it to. Do cross multiply. Just get rid of the fractions right away, right? Get rid of it. If you do a cross multiply, a plus b times 1, and if you go this way, you get that. You see, that's actually improved our situation quite a lot, isn't it? A little bit easier to deal with now. Now, we are interested in getting x on its own. Would that mean, hopefully that would mean get rid of this 4, right? And get rid of this w. So what do you need to do to both sides to get rid of both the 4 and the w? Divide both sides. What's left? I'm almost finished, isn't there? What's left?
Square root.
Square root it. Now, it's the square root of a big ugly thing. I think that's fine. I could imagine that you might, I wouldn't, but you might see that. Where did that half come from? It looks like it popped out of nowhere and the 4 disappeared, right? You think about it, isn't that 4 on the bottom? Isn't the square root of 4 2? Isn't 2 on the bottom the same thing as a half? But I would be quite happy with that. Would you agree it's just as good looking? In fact, that's probably, yeah, it's 6 of one, half a dozen of the other, right? They're both equally okay, right? And that is us for today. Any last, oh, don't do anything yet. I am now going to do a screen grab for attendance. Although I'm not sure some of you are here, so I am going to do a little sneaky thing. I am going to ask you to talk to me. And I'm going to assume that if you don't talk to me, you are never here. You just switched it on and went for dinner. Does that seem a reasonable assumption? Well, Ian is definitely here, so he must have heard me. And McKenna's been here on and off, so I don't need to worry about you lot, because I can see you. Jennifer, are you here?
Yep, I'm
You're
here.
good. Jessica, are you here? Last chance, Jessica. If you're not here, you're not getting attendance for today. You don't get attendance for switching the thing on and going away somewhere. Last chance. Okay, Jessica, you're just not here. Erica, are you here?
Yes, I'm here.
Perfect. Sydney, are you here?
Yes, I'm here.
So only Jessica. Okay. Have a nice day. We will see you all on Thursday. Anybody who's got a question? Where did Jessica go? Oh, there she is. Right, so bye-bye. As I say, if you want to talk to me, you can hang about at the end.